Get the best pizzas delivered quick. Order.
Hello, good morning. Good morning, everyone. Okay, so all of you are prepared for the exams. I think last 10, 12 days are left, right? Okay, so before we start this session, how many of you are doing inorganic chemistry, P block and D block, P block, D block, S block? Have you finished NCRT and previous year questions? Okay, see, you have last, I think, 10 days left. So you must do at least half an hour or 1 hour in organic chemistry because there is no learning into that. Maybe some point or fact that you are studying nowadays, maybe they ask directly into the exam. Okay, so whatever you are doing, do that, but don't leave inorganic chemistry these days. Okay, at least half an hour, 45 minutes, or 1 hour maximum. Whatever chapter you like, whatever chapter you feel, you must go through. Okay, and must see the, suppose you are studying theory for like half an hour, then must see the 10-15 minutes, at least 20-30 problems every day. Okay, it takes hardly for 20 problems, it takes hardly around 10 minutes, 10-15 minutes, not more than that. Okay, so you don't leave this thing. Okay, these days are very important for inorganic chemistry. Don't leave that. Okay, and next thing. Okay, next thing of physical chemistry. You have done, I think, 12th class you have done recently. What about 11th class? Have you done properly? Atomic structure, various formula you have revised? Because in atomic structure, you will get, generally, you will get formula based questions. So, formulas you have revised, radius, velocity, total energy, all these. Okay, good. Mathly. Singage, if you have finished, it's fine. Okay. Okay, atomic structure you must see because there are so much formula there. See, mole concept, you don't put so much time on mole concept. Basic concepts you have, only you see the previous year questions, like 10-15 good questions you see, and that is it. Because mole concept is a chapter, like if you can do that particular questions from that particular chapter, if you can do, you will do it in a minute. Okay, otherwise, you keep on doing for 5 minutes, you will not get the answer. Okay, so you must take care of these things. Don't waste your time in any of the questions in the exam. And mole concept, don't solve 50 or 100 problems. 10-15 selective problems you solve in mole concept. Okay, mole concept, when I say, it includes both mole concept 2, that equivalent weight concept and all, and this thing, right? And you must remember, with equivalent weight concept, You will have questions in electrochemistry also, that is Faraday's law of electrolysis. So that also you cover. Okay, don't leave that. Okay. Redox reaction, only few specific example of the redox, the oxidation state you see, and then one or two questions to balance in acidic medium and basic medium. That is it for redox. You will not get much question into that. Okay. Uh, Chemical bonding, have you revised? You must know how to calculate hybridization and all, right? Bond order, hybridization, all these things, you know. Hybridization, there is one section in coordination compound also. In coordination compound, let me tell you, don't leave that optical isomerism part. At least twice you must revise optical isomerism part and facial and meridional isomerism isomers that I have done in the class, that you must see. That is very, very important. Okay, you're going to get one question from coordination compound. So do that particular chapter very properly. Okay, in inorganic chemistry I'm talking about, right? Thermodynamics, have you finished thermochemistry? Thermochemistry is important there. Heat of formation, heat of combustion and all. Thermochemistry, you must do. And then in thermodynamics, this side, the entropy and all we have, there are very much formula, basic understanding of what formula you should apply when, that you must know. Okay, so these kind of, like, don't put so much time in one particular chapter. Okay, uh, little bit of theory. Don't read any other book. Try to, when you solve 10 questions, try to figure it out, that what new that you get from these 10 questions, what concept you understood from these particular questions. Okay, try to do that only. Okay, today also we'll solve some questions. Okay, so last class we were doing just a second, let me this one. Did you solve this question? Chemical kinetics. These three questions. I think this you have done. Let it be this one. This one you don't do. I'll give you some questions of organic chemistry. Just a second. Okay. This is a chapter of organic compound containing oxygen. Okay. And then it means this may have aldehyde, ketone, carboxylic acid, all these. Organic compound containing oxygen. 6 questions I have given you. Solve this one by one. We'll discuss this in 2-3 minutes. See, like, I'll give you 20-25 general questions, then few questions that has been asked in JEE exam. Okay, like that we'll practice. One C, Purvik is getting. One D. Tell me, first one. Most of you are getting D. Ramcharan is getting A, Ritvik is getting A, Mathili is getting A. Okay, you see, the question is arrange the following compounds in increasing order of boiling point. Okay, so we know the boiling point of any molecule is directly proportional to its molecular mass. More molecular mass, more will be the boiling point. Molecular mass is directly proportional to the boiling point. So first of all, we'll check the molecular mass. So obviously pentane has the maximum molecular mass, right? Propane, butane, and pentane, right? So pentane has maximum. So obviously C and D is not possible, right? C and D is not possible. After pentane, we have butane and then propane. So A and B order is correct, but in butane 2 all and butane 1 all, which one will have more boiling point? That's the question, right? Right? These two are what? If you write down butane 2 all, which is nothing but C, here we have OH, and butane 1 all is this. Um, OH and then C 1, 2, 3, and 4. Right? So this is butane 1 all and this is butane 2 all. So these are the isomeric alcohol, right? What kind of isomers these are? Can you tell me? What kind of isomers? What kind of isomers these two? Tell me. Position isomers, because the position of OH is different, the number of carbon atom in the parent chain is equal, right? So these two are positional isomers. So among isomeric alcohol, what can we say? Among isomeric alcohol, the boiling point in decreases with branching. As branching increases, boiling point decreases, because when branching increases, surface area decreases, and that's why the boiling point decreases, because of decrease in surface area. More branching, less will the surface area, and less will be the boiling point. So boiling point of butane 1 all is more than to that of butane 2 all. Hence the order will be option A. Right? Question number 2. Tell me. Question number 2. Question number 2. All of you are getting C. All of you are getting C. It's correct. Why you see? Fourth one is dihydroxy. Third one is 1,4-dihydroxybenzene. Right? 1,4-dihydroxybenzene, which is nothing but this OH and then again OH. So in this intermolecular hydrogen bonding possible, right? So because of intermolecular hydrogen bonding and both side intermolecular hydrogen bonding is possible, both sides. So that's why this has maximum boiling point, right? So third has maximum boiling point. This one I'm talking about, right? 1,3-dihydroxybenzene, 1,2-dihydroxybenzene. One information I would like to give you here, right? When we are talking about intermolecular hydrogen bonding, this you must remember. Intermolecular hydrogen bonding. The order of hydrogen bonding, the order of hydrogen bonding for a compound which has this kind of bonding, intermolecular hydrogen bonding, the order is ortho we have minimum, and then we have meta, and then we have para. Right? Ortho, meta, and para isomers. If you have ortho, meta, and para compounds, then the order of hydrogen bonding will be this. Means what? If the hydrogen bonding is intermolecular hydrogen bonding is possible at para position, then the tendency to forming this hydrogen bonding will be maximum. Meta will be lesser than the para position and ortho will be least. Okay, so for intermolecular hydrogen bonding, the order is this. If intramolecular is possible, intramolecular hydrogen bonding, the order of hydrogen bonding is at ortho position it will be maximum, then we have meta, and then we have para. Correct. So these two order you must remember. Now the compound that has been given here in this intermolecular hydrogen bonding is possible, right? And that's why we'll go by this order. The answer will be option C that all of you have got. So I'm not discussing beyond this. Okay, but this order you must remember in case of inter and intra. Okay, third one. What is the answer? Third one is A. This one I have discussed, so I think most of you have memorized it. No need to discuss this, right? Phenolphthalein, right? It's also given that the product gives pink color with alkali. Okay, that is the indicator that we use, phenolphthalein indicator into this. Okay, so again, you all know this, so that's good. Fourth one. See, these kind of direct question you will get in JEE mains at least. Okay, you will not, don't try to solve tough questions these days. Okay, only you solve basic questions, basic understanding. If you have, you can easily get 170 plus marks in JEE mains minimum. I'm talking about. Okay, so solve only basic questions. Fourth one, sodium phenoxide reacts with CO2 at 400 Kelvin at this pressure. What is the product we get? Wait, I'll do that. See this. Sodium phenoxide reacts with CO2 at 400 Kelvin and 4.7 atmospheric pressure. To give options are this: catechol, salicylaldehyde, sodium salicylate, and benzoic acid. Clear? Okay, I'll just increase that into the next slide. Did you get the question, Shweta? Probably this would be better. I don't know. Okay, fourth one is C. Answer is correct. Okay, so most of you are getting C only. Phenol, sodium phenoxide reacts with CO2. So sodium phenoxide is this. We have benzene, and on that benzene, ONA group is attached, which reacts with CO2. I have done the same reaction in the class, and this gives you whatever the temperature and pressure we have here that is written there. Mechanism, you know, the C double bond O and all, then this group attach onto this carbon atom, and at last this Na shift onto this CO group, and here we'll get OH. So mechanism I have done in the class, I'm not discussing it now. The answer will be OH here and COONA here, and this we call it as sodium salicylate. Option C is correct here. Tell me the fifth one. See, phenol with NaOH, write down this reaction. Phenol with NaOH CO2. Fifth one is D. Again, all of you are getting D. Aspirin. What is the formula of aspirin? I'll write down the structure. Wait. So the reaction will be this. Phenol we have OH, and this reacts with NaOH and CO2. NaOH and CO2, which gives here ONA and COONA. 2 moles of NaOH actually will take here. Okay, or sufficient NaOH. H plus and H2O when you put, we have to find out this is A with H plus and H2O. Both sodium atom is replaced by hydrogen, OH and COOH. And then we'll use this anhydride. And finally we get O as it is, COCS3. CS3COH will go out and COOH will be here as it is. This is aspirin. Okay, you must know this. Acetyl salicylic acid it is. This one is salicylic acid and this one is acetyl salicylic acid, which is also called it as aspirin. Question number 6. Option D is correct. Question number 6. What is the name of this reaction? C is correct. All of you are getting C. C is correct. What is the name of this reaction? Sixth one is Kolb's reaction, in which we'll get salicylic acid. Yeah, right, Purvik. Kolb's reaction. Okay, so name also you must keep in mind. Okay, can we move on? Next question, you see. See, all this question that I'm giving you, it is all about the organic compound containing oxygen. So it contains alcohol, phenol, ether, aldehyde, ketone, carboxylic acid. All these things, mixed question I'm giving you. Cannizzaro reaction, question number 7. Ramcharan is getting B. Shreyas is getting A. Mathili is getting B. Kushal is getting B. Okay. First of all, option B is correct here. Okay. You see here, mechanism I have already discussed. pH C double bond O H. In this, what happens? The base that you have, OH minus, this OH minus will attack onto this carbonyl carbon. This pi bond goes here. We'll get pH CO minus H, and here we have OH. Now, next, what happens? This when reacts with the another molecule of aldehyde, which is pH C double bond O H. Transfer of hydride ion takes place, right? So this hydride ion, the transfer of this hydride ion is difficult and slow. Transfer of this hydride ion means the base will attack on one of the aldehyde group, right? And one of the molecule. From that molecule only, in the next step, the hydride ion will transfer onto the carbonyl carbon of the another molecule, right? And this step is the slowest step. Transfer of hydride ion is difficult, and hence it is the slowest step, right? Hence, you see, the transfer of hydride ion to the carbonyl group is difficult. Option B is correct. Clear? Carboxylic group you can easily eliminate, not possible. Deprotonation of this, that is also not possible. Okay, attack of OH minus is the first step, which is a fast step. Nucleophile attacks quickly onto this carbonyl carbon because of the electronegativity of or polarity of this C carbon oxygen bond. Option B is correct. Clear? Question number 8. Ramcharan is getting A, Sai Meher B, Sanjana B, Pratik A, Konya A, Shreyash B, B. So A, B, A, B, A, B, you are getting like that. The structure of the compound that gives a tribromo derivative on treatment with bromine water. Okay. So when it reacts with bromine water, we'll get tribromo derivative, and that bromine will attach at ortho and para position. Right. So I think option A will correct. Okay. See, option A is what? This is metacresol, right? Here we have OH, and here we have CS3. This is metacresol. And when this reacts with bromine water, that is Br2H2O, then this bromine will attach at ortho and para position. And the product we get here is this OH, and since ortho and para position, you see this ortho and para position. These two are vacant here. So bromine, and bromine, and here we have CS3 as it is, and CS3 as it is. Sorry, OH. OH. Okay. Orthocresol, if you have, like I said, the addition of bromine is always takes place. I'm coming to that. Addition of bromine always takes place at ortho and para position. If you have this compound, which is option C, you see this CH3OH, option C. In this case, again bromine will attach at ortho and para position. But where it will attach? Those ortho and para positions, sorry, CH3, those ortho and para position which is vacant, which is available. So here we are getting dibromo derivative. Just a second, I'm coming. Someone's there. Yeah, so bromine will attach at ortho and para position. So this is the answer for the third one. When you take this option B, okay, in this also will get dibromo derivative, right? In this also will get here and here will get bromine, not at this position. Okay. Option B, if you take, when we have CS3, CS, in this we'll get monobromo derivative. We'll get ortho and para product, right? Like this. If you have CS2OH attached over here with bromine water, we'll get ortho and para substituted product. CS2OH bromine will attach here plus CH2OH bromine will attach here. This is a reaction given in the book. I think you forgot. But when we have OH present here at this position, right, then we'll get mono substituted. I have done this also, like why we get mono substituted and this thing here. In this case, you see, when we have OH present here, this position, ortho position, will become highly reactive, right? And at the same time, either see any of these two position, ortho and para position, when you have OH present here, then the effect of this group will be same at this position and this position, right? And it depends on the solvent also here. You see, uh, the structure of the compound that gives a tribromo derivative on treatment with bromine water, right? So the point is, when you have this, it's not like we not get, like in organic chemistry, we cannot neglect any of the answer in this. The point is, the major product we have to discuss, right? So here the major product will be bromine will attach at ortho and para position. Here also it will attach ortho and para positions. Why? Because OH is attached directly to the ring. But when OH, like I told you already this, when OH is attached directly, not attached on the ring, then we'll get ortho and para substituted product like this. And in one of these, this para product will be slightly more dominant or major product we have here, right? So that's the reason in option B we'll get mono derivative or mono bromo product here. C and D will get dibromo product, and A will get tribromo product or tri-derivative, tri-bromo derivative, whatever you say. Is it clear? Yes. So you must remember there are many reason we have here, but what key point you have to keep in mind that this is the reaction of when we have OH group attached directly to the ring. Here it is not attached directly. Okay. Whenever OH attached directly to the ring, then the bromine or the halogen group, mainly we take bromine only, will directly attach to the ortho and para position of the ring, right? If it is available, right? So here you see this position is not available, so accordingly the bromine will attach another position. Okay, so that's the thing you have to keep in mind. Okay, question number 9. Ninth one is D C. Oh, some of you are getting D, some of you are getting C. Ramcharan is getting C. Ritik D, Aditi D, Sai Mahir C, Mathli C, Kushal C. Vaishnavi is getting D. Sayuja is getting D. Okay, now you see when we have paracresol, tell me what is the name of this reaction? Paracresol is this. We have OHCS3 plus it reacts with chloroform, which is CHCl3 in alkaline medium. So for that we'll write OH minus. Gives a compound A. So in this case, this reaction is Reimer-Tiemann reaction, if you remember. And in Reimer-Tiemann reaction, CHO group will attach with the ring. CH3 will be as it is since it is there. Okay. So this reaction is Reimer-Tiemann reaction. So the product will be this. Now the next thing is what? That in this A, this is A, we add what? HCN into it. So where this HCN will go? This will obviously react onto this carbonyl carbon, most reactive, right? So Cn minus and H plus will attach simply onto this. Okay, so the product here it will be OHCH3 and C double bond O that I will not write. This Cn minus will come over here and this H plus will come onto this carb in this oxygen. So we'll get OH here. Fine. Now when you do the acidic hydrolysis of this H plus H2O, that is what the case we have. Acidic hydrolysis. Then what happens in acidic hydrolysis of cyanide group? It converts into what? Carboxylic acid. When you do the acidic hydrolysis of any cyanide group, that will convert into carboxylic acid, which is given in the question itself. The structure of the carboxylic acid we have to find out. So OH will be as it is, H will be as it is, COH. So I think option C is correct. Adjacent to OH, ortho position, option C is correct. Understood? Some of you are saying D. You may not concentrate on this. We have OH here and CS3 here. So ortho position of OH will be this, not this. Will this product form? Like major product will be this, but what about this? This product will form or not? We'll get this product, will not get this product because this is the meta position of OH group. So reaction will not take place in meta position. Okay. If it is at ortho, then little bit of this amount also will get. Okay. Yeah, correct, Purveen. So that's the another no question. But again, can we move on next? Third one. It's not very clear. Question number 10. I'll just zoom in. A liquid was mixed with ethanol and a drop of concentrated H2SO4 was added. See this. 10th one you are getting D. Why it is D? All of you are getting D, so D is correct. But why it is D? Like you have done this, or or you have seen this question before. Which compound gives this fruity smell? Only acid gives ester. Okay, so that's the thing. Ester is formed. Ester. Yeah, it's correct. Correct. See, one more thing you must keep in mind, since this logic you have applied, that acid may give ester, that you have that. Yeah, that's why you selected D. That is correct. But fruity smell is given by esters only. Fruity smell is the characteristics property of ester, right? So you must get ester as a compound, which is only possible when acid reacts with uh, alcohol in what, in acidic condition, right? So that's why the answer is option D, right? So fruity smell is the characteristics for acid plus alcohol gives you ester, and ester gives fruity smell, so that's why acid is the answer. Okay, 11th one. Option D, you see, I don't have a space. Option D is this. Okay, CS2, 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 OH. Now you see this question. Question number 11. C9H12O. The compound is, if it is not visible, the compound is, sorry, just a second. The compound is C9H12O. The question is, a compound is given which is C9H12O, have four isomeric structures. Okay, four different structure you can draw for C9H12O. All the compounds react with sodium to give odorless and colorless gas except one, right? Means what? The four different structure that you have here, out of the four, all um, reacts with sodium and gives odorless and colorless gas except one. Means one molecule does not react. Next information is what? The three out of the four are pre-oxidized by hot KMnO4, right? Means out of the four compounds, three is getting oxidized by KMnO4 to produce benzoic acid. One another isomer does not respond to iodoform test, right? One of the four does not respond to iodoform test, but one isomer out of these four fulfills all condition the isomer is. Okay, the question is, for a given compound there are four isomeric structure possible, and for all those isomeric structures different 3 4 conditions are given, right? On the basis of these conditions you have to identify the isomeric structures. Okay, okay, now you see, I'll just solve this one. Okay, you see, the formula is C9H12O, right? This is the formula of the compound, and for this the possible structure if you draw, that will be CnH2nOH. General formula is this. Unknown compounds have four isomeric structure. Can you tell me what is the DOU of this, degree of unsaturation? What is the DOU of this compound? Yeah, it's correct. It's 4. Because the formula of DOU is what? It's not 1 Vaishnavi. Formula of DOU is this: C plus 1 minus H plus X minus N divided by 2. So C plus 1 is 10, minus H is 12, X is 0, N is 0. So DOU is 4. It means 4 unsaturation is there. That's why this formula represents it's a benzyl alcohol. And the general formula of benzyl alcohol is this: CnH2nOH. Okay, benzyl alcohol. You see, one ring and 3 double bonds. So 3 plus 1, 4 degree of unsaturation. That's what we are getting here. So this formula actually represents that it is a benzyl alcohol. Now, since the formula of this is given, so the possible isomers of these of this molecular formula is C9H12O. The possible isomers of this is, I'm drawing here, CH CH2OH CH3. Another one we can write CH2O CH2 CH3. Next one is this CH CH3 CH3OH, and the last one is CH2 CH CH3OH. Okay, now you see this particular compound, this does not give iodoform test. Does not give iodoform test. Okay, this one has CHOH CH3. It gives iodoform test. Right, and this actually, this one also, that does this gives iodoform test? Right, this one does not liberate H2. Liberate H2. Only this can liberate H2 and maybe oxidize also. So this molecule fulfills all the condition that is given in the question. Okay, that's why this one, where is this CH2 CH CH3 OH, CH2 CH CH3, option A is correct into this one. Understood? So for this kind of question, you should know the property of alcohol, ether. Why it does not give H2? H2 because this does not oxygen, it's the ether, right? So this oxygen does not contain hydrogen. That's why H2 is not possible into this one. Okay, so option A is correct. Is it clear? See, only one thing if you keep in mind, like this does not give iodoform test, right? This also does not give iodoform test, and this also won't give iodoform test. So only one of the molecule gives iodoform test, and that's why this molecule has to fulfill all the condition given in the question. And that's why the answer is this one. If you have the information of hydroform test only, you can do this question. Okay. Next one. Question number 12. Question number 12. Tell me. P and Q is given. We'll do the acidic hydrolysis of this, and the product that we get can be distinguished by. First of all, you check what is the product you are getting into this. Purvik is getting B, Samir D, Mathli C, Ritvik Kushal D. Question number 12, Shresh. Ramcharan is getting A. Okay, okay. I see. The answer in this is option C, failing solution. How you see this? First of all, like I said, you have to first form the product, right? So P, the compound P we have is this H2C double bond COCOCH3, and here we have CH3. This is P. When you do the acidic hydrolysis of this, so obviously this CH3CO group that we have here, that will form CH3COOH, right? And OH group will attach to this H2C double bond C OH. We have CS3 plus will get CS3COOH. Now in this is the enol form, and keto-enol tautomerism we can easily product we can write down. Okay, so with keto-enol tautomerism, what happens? This double bond will go here, and this H plus will attach onto this carbon atom. So we'll get CS3 C double bond O CS3. So we are getting ketone into this. Fine. Now Q we have, which is nothing but CH3 CH double bond CH OC double bond O CH3. Again, when you do the acidic hydrolysis of this, same kind of reaction takes place. CH3COOH will go out, and here we get CH3CH double bond CHOH. Again, keto-enol tautomerism will takes place. This pi bond will go here, H plus will attach here. So CH3 CH2 C double bond O, and hydrogen will be as it is. So here we are getting ketone, and here we are getting aldehyde, which can be easily differentiated by failing solution. Option C is correct. Clear? Failing solution. Lucas reagent we use for alcohol, right? But here we are getting aldehyde and ketone. NaHSO3, when we use NaHSO3, see NaHSO3 we use for the compounds which have larger group present around the oxygen atom. Larger means larger than CH3 group. Like we have acetophenone. Acetophenone we use NaHSO3. Okay. And one more thing you write down here about Na, since most of you are saying D, so write down NaHSO3 reacts both with aldehyde and ketone. Where we have like two reaction, I'll write down probably these two reactions you see. Suppose I'm taking aldehyde CS3CHO. So like we have CS3 C double bond O H reacts with NaHSO3, so Na plus HSO3 minus. The product we get here CH3 C single bond OH, and this H is coming from here. This hydrogen is there. And here we have hydrogen of carbon, this hydrogen is here. And we have SO3 minus Na plus. Like this we have the salt. Same kind of reaction we have with ketone also. Like suppose if I write down in this only, suppose instead of this hydrogen if you have CS3, then here also instead of this hydrogen we'll get CS3 and the product will be same. So you see the aldehyde and ketone does not both reacts with NaHSO3, so we cannot distinguish with these two, this reagent. Okay, so you must remember this. Whenever in the option you see failing solution and all, try to get aldehyde and ketone. You must think about the question is related with aldehyde and ketone. Okay. Okay. Next question you see question number 13. Just a second. Thirteen is C. Yeah, you see this. In resonant reaction, RCOCl plus H2 gives this BaSO4 here. For this kind of question, you should know the mechanism. The mechanism helps you. So the property of BaSO4 is what? See, this palladium is highly reactive. Okay. And with this nature of palladium, when you're using palladium into this reaction, the reaction is very difficult to control. Okay. 2,4-DNP. I'll tell you, Ramsey, just a second. Let me finish this. Okay. So uh, when we use this PDBSO4, so palladium is highly reactive in nature, right? So without and this reactive nature of palladium, with because of that only the reaction is very difficult to control, right? So we need to deactivate palladium little bit, okay? And for that purpose only, we are using we are using BaSO4. So answer in this question will be it deactivates the nature of or it deactivates palladium simply. Okay. See, so answer will be option C. In the previous question, I'll just give you the, what is 2,4-DNP. Just you write down this. See, 2,4-DNP is 2,4 dinitrophenyl. Nitrophenyl hydrazine. Okay. The structure, can you write? Okay, I'll write down. You won't be able to write it. The structure of this will be 2,4 dinitrophenyl hydrazine. So hydrazine is what? NH2NH2. With NH2NH2, this phenyl group is attached, right? So NH2, this is NH and this is NH2, NO2 and NO2. So you see 2,4 dinitrophenyl, the structure is this. Okay. If you see the test of this, just a second, the dilution prepares. Okay. Okay, write down. This is 2,4-diphenyl hydrazine. When you do the test of it, we'll use little bit of amount of methanol, that is CH3OH, and sulfuric acid also, H2SO4. So all these mixture, we call it as Brady's reagent. BRADYS. Brady's reagent. This name you also remember. Okay. See the two nitro groups that we have here. So in reaction, what happens? This reaction is slightly dependent on the nature of aldehyde or ketone that we are getting. Right? So when we have any aldehyde, let's write down the reaction here. Suppose if you have like both reacts with aldehyde and ketone first of all. So again, this won't distinguish. But how it reacts, that you see. When this reacts with 2,4-dinitrophenol into this. So what it's the reaction is very simple. You see, I write down this NH2, NH, and then we have the ring which contains NO2 group at 2 and 4 position. So this H2 and this O comes out as H2O, right? And this 2 joins this O and H2 comes out, and this 2 joins this N and H, and then we have ring over here with NO2 group. Sorry, NO2 group. And here it will be R and R. Okay. Now this R and R can be two different alkyl group also, can be same alkyl group also. One can be alkyl group, other one can be hydrogen also. In the case of aldehyde, it is right. Now in this kind of reaction, again it is a condensation reaction because H2O is coming out, right? So since one molecule of H2O is coming out and the two molecule joins together, so reaction is condensation reaction, right? And this actually involves the nucleophilic addition and elimination reaction, right? Elimination of water molecule takes place and carbon and nitrogen is joined together, right? So it is addition, example of addition elimination reaction. Okay. Now the point is, by the use of this reaction, we can just understand or find out the presence of carbon oxygen double bond. Okay, where the carbon oxygen double bond is present. Okay, One important point in this you write down, note down this point I am dictating you. Using this reaction, using this reaction, we can understand, we can understand the presence of carbon oxygen double bond and we get, this is important, and we get an orange or yellow precipitate and we get an orange or yellow precipitate from a carbon oxygen double bond, from a carbon oxygen double bond in an aldehyde or ketone. Okay, so we'll get orange or yellow precipitate into this. Okay, from that we can identify specific aldehyde or ketone. Okay, with that precipitate, but that is not required. The point is, since both aldehyde and ketone reacts with this 2,4-DNP, that's why we cannot use this particular reagent to distinguish the two compound, that is aldehyde and ketone. Clear? So this property you must keep in mind. 25 carbonyl group, yes. Yes, simply you can say it is there to identify carbonyl group C double bond O. We cannot distinguish aldehyde or ketone, but yes, we can understand whether double bond C or carbon oxygen double bond is present or not. And how do we get this? Because H2O is eliminating, condensation reaction is there. Okay. Next one you see, question number 13 we have done just now, right? Question number 14. Can you see this? Which of the following carbonyl compounds, I'll just check, carbonyl compounds on condensation gives an aromatic compounds? Which of the following carbonyl compounds on condensation gives aromatic compounds? Yeah, C is correct. C is 2 moles of the compounds will take. C is correct, Samir. 2CH3 COCH3. HCHO is not possible. For aromatic compounds, we must have at least 6 carbon atom, right? And with that only it is possible if you take 2 molecules of this or 2 molecules of this. Aldehyde won't give you this. Okay, this may give you because of the symmetry also you can understand. Okay, so 14 C is correct. Question number 15. Just a name reaction. Question number 15. When we use HVZ, Helvolard Zelinsky. Stephen's reaction is correct. Stephen's reaction is correct. Alkyl cyanide gives aldehyde. The reaction is known as Stephen's reaction. That's a named reaction it is given. Okay, done. So Stephen's reaction is the answer. 15, 16, sorry, 15. A is correct. Next one. Yeah, correct, Purvik. Correct. So all these reaction you see, all these whatever see, you're solving question number 15, but there are four name reaction is given. So it's not like only actually Stephens is the answer, so it's fine. You should know all the four things, four options. What is this 14th? See, actually, we are getting aromatic compounds. Okay. For aromatic compounds, we must have six carbon atom, right? Six carbon atom, and all these molecules actually it is understood that we are getting only we cannot take only one molecule of all these A, B, C, D, the option that is given. We can take at least two molecules you have to take, right? So when you take the two molecule of CS3 C double bond O mechanism, I am not explaining. So what you can understand, when you take two molecules of this and both molecule clubs together, right, and H2O molecule goes out. Okay, so you see this H2O goes out from here, and then another molecule we have CS3 C double bond O, CS3, right? So we are taking two molecules of this, fine. So when these two combines, you can see there is a possibility of forming what? A ring here. When these two combines, so we'll get a ring over here, and this H2O and this H2O oxygen will come out. Okay, so H2O molecules comes out. We have CH3 here, CH3 here, double bond, single bond, double bond. Okay, okay, so acha, one more thing you see. See, we have CH3. I'll just write down this and CH3. In this, the question is on condensation. So obviously condensation is given, so H2O molecules will go out, right? So when you have this with another molecule, right? So 1, 2, 3 and 1, 2, 3. So if you take simply one more molecule here, so this is H2O, this H2O goes out, we'll get a bond here. And if you take one more here, CS3 C double bond O, CS3. So 1, 2, 3, these two will join. One will come here. Okay. So you see here, to understand this, I think I have to discuss the mechanism only. Fine. So what happens? Condensation is taking place, right? So H2O will go out, and will heat this simply, and H2O will go out. right? So one possibility is what, that this oxygen will take this hydrogen atom from here, right, and will get a double bond here, correct? And what happens, we are actually taking here three molecules of this. Why? Because you see, one CS3 is here and one CS3 is here. So one of these CS3 molecule will take part into the condensation reaction and H2O molecule will go out. And here also we'll have the same thing. So either suppose these two are, this is reacting with this is reacting with this will be left behind, which will not take part in the reaction. Correct? And from this, again, when you heat this, from this H2 molecule goes out, from this H2 molecule goes out, from this H2 molecule goes out. So we are getting three H2O molecule will go out from this, right? And since this carbon and this carbon, again, since we have double bond here and single bond here, so only three bonds with this carbon atom, right? So from this H2 molecule that goes out, this carbon atom will join as a bridge between these two carbon atoms, right? And the structure that we get here, I'm not giving you the exact mechanism here, right, but little bit of idea you will get. This, the third molecule, will act as a bridge between this molecule and this molecule, right, and we get a six membered ring compound like this, and on which these two joints, like 1 2 3 4 5 6 here, one CS3 is left, one CS3 is here, so this CS3 will be attached here, here, and here. Correct? So if I take this as, suppose, if I write down the number, then probably you can understand 1 2 and 3. Okay, 1 2 and 3. So this CS3 will have here, and here we have 4 5 and 6. So 1 2 3 4 5 and 6, and this H2O goes out. So this 7 will join with this 6. 7 8 and 9, correct? So 7, this 7 8 and 9. So like this it joins, you see. This carbon 2 1 2 and 3, this 3 joins with 5, and this carbon joins with this carbon here, eighth one, right? So like this the ring forms. Okay, and this CS3 will be there at alternate position. Okay, you have to actually memorize this. The name of this, why it is important, because the name of this, sometimes they have asked this, mesitylene. The name of this is mesitylene, and they have also asked the degree of unsaturation of mesitylene. That's why this one is important. Okay, that's why this one is important. So degree, what is the value of degree of unsaturation of mesitylene? Degree of unsaturation of mesitylene, what is the answer? 4. One ring and 3 double bond. 4. So this question they have asked. So you must memorize this structure of mesitylene. Okay. This kind of condensation reaction, chain reaction, which is one molecule is connecting with 2 and 2 is connecting with third. It is not possible when the unsaturation or this carbonyl group present at the on the terminal carbon, like in the case of this one, D option, aldehyde. It is not possible over there. Okay, that's why this acetone gives this kind of reaction, and not acetone. This gives this kind of reaction. Yeah, acetone gives this kind of reaction. So you have to memorize the structure of this mesitylene and degree of unsaturation into this. Anyways, so 16th one we have done. Next one you see, 1, 2, 3, fourth one. Question number 16. Hmm. If it is possible, I can display. It's not covering the whole question. This is because in one pick I have taken 4 or 5 questions. No, that's why the font size is small. 16 is a simple one, Canizaro. Y is alcohol, D is deuterium, XY will have the structure. 16, Ramcharan is getting A, Sanjana is getting B, Saimir B, Kushal B, Pratik B, all of you are getting B except Shweta and Ramcharan. Okay, what happened in this? This OH minus will attack onto this carbon, right? And this pi electron goes onto this oxygen. One molecule we are taking of this. And then this D minus will go out. We'll get C double bond O again here. And finally, H minus also will go out. So we'll get carboxylate ion, which is X. I think A is correct. C double bond O, O minus. And alcohol is this. I think A is correct. We'll do this. Wait. You see the question, the compound we have here, D, C single bond D, double bond O. And we are taking OH minus here. So this OH minus will attack onto this carbon atom, pi electron goes here. And we get D, C single bond D, O minus OH. And then this D will go out as D plus, minus D plus, and this bond pair, sorry, it's not D minus, no, then only we'll get the double bond. D minus. Okay, I'll just correct it. As D minus, and we'll get double bond here. So we'll get D C double bond O OH, and finally when you heat this, H plus will go out, and we'll get D C double bond O minus carboxylate ion. Okay, so X is this. Now, when this reacts with Y is an alcohol, so how do we get alcohol? How do we get alcohol? You see, the structure is this: D C double bond O and D we have here. Okay, D plus OH minus if we are taking, or H plus OH minus H2O. D is just isotope of it. So when this pi electron goes here, right? So D plus will attach. We have to form alcohol, right? So OH we have to get. Fine. For OH we required, because we have already H plus there, D C D double bond O. So this will come here. Here we have OH O minus. So for that we required H plus and D minus will take. Right. So this D minus will attack onto this carbon atom. So we'll get D C single bond D. D O minus will take this H plus, will get OH. And we are getting option A is correct. See, I am taking this H plus and D minus according to the option, okay, because nothing is given in this question. If you are getting OH here, it means this O minus should take that H plus. That's why I have taken H plus. For the here also you see, you must take H plus so that OH you'll get. Here also the same thing, right? And in these two options you see, we have D. I think option B is also possible if you take H2O. Oh no, one thing. Let's just one thing. Oh, fine. No, it is correct. Yeah, it's correct. See what happens here. Uh, this one molecule we have used over here, and in this molecule D minus is going out. This D minus we are using here, and you see H plus is also going out, which we are using here. So this H plus is coming over here, D minus is coming over here, and that's why option A is correct. Understood? Fine. Next, question number 17. Do this. 17, you are getting B. How it is B? How it is B? Okay, only tertiary alcohol. An alcohol A, when heated with copper, gives a product B, not having oxygen atom. B on ozonolysis gives two isomeric products C and D. C on oxidation gives monobasic acid E. Silver salt of which contains this percent of Ag, the structure of A is. Okay, so ozonolysis possible uh, in alkene, right? If you have any unsaturation, and that is possible if you have tertiary alcohol, because that only from that only will get the elimination reaction takes place, and we'll get the alkene into that dehydration. Correct. So tertiary alcohol gives you alkene first, and then ozonolysis takes place. Fine. This is what you have done. Yeah, it's correct. B option is correct. 17B is correct. Yes, only tertiary alcohol gives you alkene, and then ozonolysis takes place. So B is correct. Now you do this 18, 19, and 20. It's solve 18 and 19 first, then we'll do the 20. A, Shweta is getting D, Atmesh is getting A, Sai Mihir D, Ritvik D, Mathili A, Pratik A, Kaulinya A, Ramcharan C. This one is a bit easier. You see, answer D is correct. Option D is correct. You see, this acid gives you H plus, right? So this H plus will come onto this oxygen. So we'll get OH positive charge onto it, right? Next, we are heating it also. So because of this heating, what happens? This bond pair, this will dissociate because oxygen will have the positive charge here. This bond pair will shift over here, and this sigma bond comes over here. The sigma electron comes over here, and this bond will dissociate, right? And since this pi electron shift over here, so we'll get positive charge here, right? Where the chlorine will attach onto the next step, right? So that's why phenol and 3-chloro-1-butene will be the answer. You see this, I'll write down the reaction. See, the question is this. Lone pair we have here. And when we use H plus Cl minus, so this H plus will attach here. So we have phenyl OH positive charge. Now this bond pair goes here and this bond pair goes here. So we'll get PHOH, which is phenol, plus we'll get this double bond and this, where we have the positive charge here. This carbon will have the positive charge. And with this, the Cl minus will attach over here and the product will be this 3-chloro-but-1-ene. Question number 18. What is the following true regarding why it is produced as pure single enantiomer? Why is a mixture of pair of geometrical isomers? Why is a reciproc mixture? And why is chiral? What is the answer? 18. How do we get single enantiomer? 19th one. See, first of all, this is Y and this is X. So Y is forming from this carbocation, right? Which is planar, sp2 hybridized. So attack of chlorine can be from any of the side, from this side also and that side also, right? So we'll get two different configuration, and that's why it is a reciproc mixture. The probability is equal of Cl minus to attack from both sides, from the top or from the bottom. That's why we'll get a reciproc mixture. We have a chiral carbon in this. In Y, we have a chiral carbon. But it is saying Y is achiral. Clear? Question number 20. Question number 20. Okay, wait. We'll do it. I don't think there is an option of no, option to crop this. That I can do initially only when I was adding the question. I don't think it's possible here. But I'll take care of it next time. Okay, I'll not take 4 or 5 questions in one pick. Okay, 2 3 questions will take so that the size will be font size will be bigger then. Okay, I'll check that. First you do this. I'll figure out that option. 20 you're getting A. How? Samir. Anyone? Question number 20. NaCl will go out. According to the option, you try to uh, do this. Tell me quickly. You're getting C. Okay. See, why is this double bond? C2H5 ONA. When this Na plus will take this Cl minus and will get what? Positive charge here, and NaCl will form. Right? You see the option here. 1,3-butadiene is one of the option we have, and 1,2-butadiene. So 1,2-butadiene is not possible, because removal of H plus is possible from this carbon atom. So when the H plus removal from this, so this plus and this negative will form a double bond here, and this double bond will be as it is. Right? So option 1 is possible like this, or if another way, if you see, we have double bond here, and OC2H5 will join here. This is not there in the option. CH3 CH double bond CHOC2H5. we have. So this is even not there in the option. Okay, so my point is you can get confused into these two, because when H plus will come out, so that C2H5O minus we have there, that will take that H plus and form C2H5OH, which is already there in the solution. Right? In the option it is given C2H5OH we are getting here. Or we are taking C2H5ONA or C2H5ONA. So both what happens, either in this case it will form NaCl, and in this case it will form HCl. Right? So if OC2H5 will join here, right? See, they're asking major product, right? Major product. So major product will be what? In these two. In these two, which one is the major product? Depending upon the stability, right? Two possible product will be this one. One is 1,3-butadiene and other one is this. So whatever the product here we the decision for making this like which one will be the major product is difficult over here, right? We have to have some factual information here which is not given in the question. That's why the only one option is given in the question, which is nothing but A. Is it clear? Tell me. Right. Okay, so it's 11:15 now. We'll take a break. Okay, I will start at 11:30. Okay, half an hour we are left with. So we'll start at 11:30 sharp. Okay. And tomorrow, do you guys have any other class tomorrow? Physics or maths? All of you, I'm asking. Okay. So tomorrow I'm planning to take these classes till 28. Okay, continuously I'll take the class. Okay, anyways, I'll let you know in the evening about tomorrow's class. Okay. So we'll start the class at 11:30 again, and then we'll take till 12 o'clock. Okay. Fine, fine. So HSR guys, accordingly, I'll send you the schedule. Okay, so don't worry with that. Okay, so we'll take a break now. We'll start at 11:30. Okay, can we start? Okay, this one we have done. These two. Tell me what is the answer? What happened? I'll give you a hint here. You see, this reagent is for Perkin reaction. This anhydride and this salt we use for Perkin reaction. And the property here you have to you should know, or the information that you should have here, that effervescence with NaFCO3, the compound which gives effervescence with NaSCO3 is carboxylic acid. This you should know. The compound which gives effervescence with NaSCO3 is carboxylic acid. Okay? And positive Bayer test means what? Bayer's test is the test of unsaturation. Right? It means in this compound, we must have any double bond present. Then only test of unsaturation will be there. Right? Ramchandra is getting D, right? Okay, not D. Okay, so the product here J will be a carboxylic acid with at least one double bond. That's the information we should have from this data, given data. Or if you see that DOU of this, if you calculate, that also probably you'll get 2 or 3. You can check. What is the DOU of this, you tell me? Degree of unsaturation of C9H8O2. Yeah, C is correct, Ramchand. C is correct. See, the degree of unsaturation of C9H8O2 for J, which is C9H8O2, it is 6 if you calculate. 9 plus 1 is 10, 8 by 2 is 4, 10 minus 4 is 6. Okay. And what is Perkin reaction? In Perkin reaction, benzaldehyde, CHO, reacts with this reagent, CS3CO whole twice O, CS3CO Na, and it gives C6H5 CH double bond CHCOOH, which is probably Z. Sorry, Z. Correct? You see the unsaturation here, C6H5 phenyl groups, one ring, three double bond, 4, 5, and one double bond here, 6. Okay? So this is the carboxylic acid we have, gives effervescence with NaHCO3, and double bond gives positive Bayer's test. Okay, now when this is allowed to react with H2 PD, right, the reduction takes place and we'll get C6H5 CH2 COOH, hydrogen atom will attach. Now after this it is easy, SOCl2, chlorine will attach with this, C6H5 CH2 COCl. Correct? And in the last we have anhydrous AlCl3. This will take this Cl minus from here. So if I write down the structure of this, CH2 C double bond O Cl. Okay. This AlCl3 will take this Cl minus, forms AlCl4 minus here, and this carbon will attack onto this carbon and joins. Okay, so we'll get 1, 2, 3, and this will attach with this ring. So the product will be this here. Two double bond O, like this we get. Clear? Option C is correct. What about 35? I also I have taken. This is it. This is I. So this is it. Option A. Sorry. This is nothing but K J I. Okay, next question. Now see, these are the questions has been asked in JE. Question number 70. Wait, I'll just. Now fine. All of you are getting C. What is this reaction? Answer is correct. C is correct. What is this reaction? Only Canizaro. This is an example of aldol condensation, repeated aldol condensation followed by Canizaro reaction. Okay. Your answer is correct. 3 is the answer. All of you have done, or do I have to do this? Let me know. You want me to do this or what? Okay. The number of aldol reaction that occurs in the given transformation is. Okay. So, okay. I'll just explain this in the next one. It's a big mechanism we have. So you see the step 1 in this reaction. We have CH3, CHO, and the reaction is going in basic medium. And if you remember, in this what happens, the alpha hydrogen takes part in the reaction. So this hydrogen will take this OH minus H2O forms and will get CH2 CHO with one lone pair on it, and H2O will get here. Now the another molecule, which is HCHO, 4 molecules of this we have. So the first one is this, plus CH2CHO, lone pair on this carbon, or negative charge also you can write. That gives, which is a reversible reaction here, HCO minus HCH2CHO. So what happens here, you see? This lone pair will attack onto this carbon atom, and this pi bond goes onto the oxygen. Okay? And in presence of H2O, next, this gives you this H plus will come over here, OH minus will be as it is. So we'll have, excuse me, CH2OH, CH2CHO. This is the step 1 reaction. Now again you see what happens. Since we have 4 molecules of HCHO, only one I have used now. Okay, so one I have used, and we have got one OH here. Similarly, you have to keep on writing down the steps involved here. You see the second step. What happens into this? Step 2. Now one molecule is this, and another one is HCHO. So again, what happens? This one, CH2OH, CH2CHO, which is this molecule, plus the base we have OH minus, and again this will take the alpha hydrogen, which is this, right? And we get what? HO, CH2 CH minus, CHO plus H2O. So basically you can do this question in one single step. I am giving you the mechanism, how do we get the product here. But since the question is how many reactions are there, so it depends on the number of alpha hydrogen that is present, because you see this OH minus will take this alpha hydrogen, one step. Again this OH minus will take this alpha hydrogen, another step. And the third one we have one more left. So one more step we have after this. Okay. So we'll get this again in this one. The second step is what? This compound, which is HCHO, we have plus CHCHO with lone pair here, and CH2OH is attached with this. So again, what happens? This lone pair will attack onto this exactly same step, and this pi electron goes here. You see, we have HCO minus H, which is nothing but this molecule, is attached with CH, CH2OH, CHO, and again with H2O, it gives HCOH, H, and then CH, CH2OH, CHO. Did you understand this? Now in the step 3, what happens? This is the molecule we have, and this alpha hydrogen will take part in the reaction. So again, you see, we are getting one OH here, another OH here, and then again in the next station we'll get OH here. Okay, and then next you'll get the product which is given in the question. Can you write down the step 3, or you understood, or should I write down again? Step 3. Fine. So you can write down, you will get the product. Okay. So it's actually depends on the number of alpha hydrogen that we have. Okay. Next question. Question number 71. Finish it fast. I have another class also after this, after 12. The compound that undergoes decarboxylation most readily under mild condition. 71 is B, correct. See, I'll give you this. This is just information you should have. B is beta keto acid. Okay. This is alpha position, and this is beta position. So when you have the beta keto acid undergoes decarboxylation in very mild condition, means what? If you simply heat this slightly, if you heat, decarboxylation takes place. Usually decarboxylation of carboxylic acid requires catalyst, okay, for decarboxylation, right? For any carboxylic acid, if you have, so on simple heating it won't decarboxylate. So for that purpose you have to add some catalyst into it. But if the carboxylic acid is beta keto carboxylic acid, then its decarboxylation is very easy under mild condition, like on simple heating. So that's why the answer is option B. This point you write down in your notes. Clear? $72. Okay, I said the decarboxylation of beta keto acid. Beta keto acid means what? At beta position we have ketone group present. Okay. The decarboxylation of beta keto acid is very easy. Is very easy. But for ordinary carboxylic acid, for ordinary carboxylic acid, beta, sorry, ordinary carboxylic acid decarboxylation requires ordinary carboxylic acid decarboxylation requires catalyst. In bracket you write down soda lime. Catalyst we use soda lime. One more thing I forgot to tell you, decarboxylation of beta keto acid which contains alpha hydrogen also you write down. Alpha hydrogen must be present in beta keto acid. Here you must have at alpha position you must have hydrogen present, alpha hydrogen. Question number 72. Question number 72. A is correct. Option A. In option B, you will have H plus and Cl minus will attach here. See, when you have HCl, ZnHCl, then H plus and Cl minus will attach onto these two carbon atoms. So HCl actually, HCl attacks on 2-degree alcohol as well as double bonded carbon atom also. Right? HCl attacks on 2-degree alcohol as well as double bonded carbon atom also. So in this case, what happens when you take HCl? Here only I write down here you'll instead of OH you'll get Cl, and here we'll get Cl will attach over here and hydrogen will attach over here. The product we get here is this Cl, CHCl, CH2, CH2, CH3. CH2 COCH3, sorry, CH2 COCH3. This is the product you'll get in case of ZnHCl. Right? Answer will be option A. Okay. With NaBH4 the product will be very less. Okay. Na with liquid Na3 will replace this H from here. ONA will get over here. If double bond is not there, where double bond? If double bond is not there, then the product will be different, no? See, in this question, yeah, then it is possible. If alcohol is not there, then it is possible, yes. then that's what in organic chemistry, one group or one reagent, if you change, the whole answer will change. Okay, but yes, if alcohol is not there, then it is fine. Fine. 73. Iodoform test. I think D is correct. 73. Yeah, D is correct. Iodoform can be prepared from all except isobutyl alcohol. 2-degree alcohol we required. Okay. 2-degree alcohol forms iodoform. You must keep this in mind. 2-degree alcohol forms iodoform. Isobutyl alcohol is 1 degree. 73 is D. Okay. 74. 2,4,6 tribromophenol. I have done this in the class, right? 2,4,6 tribromophenol. 74 D is correct. Understood, all of you? Done? Okay, so we'll wind up the class here only. I have another class at 1 o'clock. Okay, so tomorrow I'll send you the timing. Okay, when we have the class. Okay, tomorrow we'll do amines. We'll solve the question of amines. Plus, we'll also try to cover up atomic structure and chemical bonding. Right? So you must revise amines, atomic structure, and chemical bonding. Okay, we'll do that tomorrow. Okay, thank you.